The equation of the first circle is x minus 1 whole square plus y minus 3 whole square is equal to r square. Therefore, the coordinates of the center of the circle are 1, 3 and the radius is equal to r. The equation of the second circle can be written as x square minus 8x plus y square plus 2y is equal to minus 8. On the left hand side, add 16 to the first bracket and 1 to the second bracket and add 17 to the right hand side. Therefore, the equation of the circle becomes x minus 4 whole square plus y plus 1 whole square is equal to 9, which can be written as 3 square. Therefore, the coordinates of the center of the second circle are 4 minus 1 and the radius is equal to 3. Now consider a situation where these two circles touch each other externally. The first circle has its center at 1, 3. Let's denote this point by C1. The second circle has its center at 4 minus 1. Let's denote it by C2. The radius of the first circle is equal to r and the radius of the second circle is equal to 3. Therefore, these two circles touch each other externally if the distance between C1 and C2 is equal to the sum of the radii. Therefore, C1, C2 is equal to r plus 3. Now imagine that the radius of the first circle, r, starts increasing. When that happens, the first circle expands and it starts cutting the second circle at two distinct points. Now as r increases, r plus 3 will become greater than the distance between C1 and C2. Let's call this result 1. Now consider a second situation where the two circles touch each other internally. So we have the first circle with center at the point C1 with coordinates 1, 3. And imagine that the second circle with center at C2 with coordinates 4 minus 1 is contained within the first circle and touches it internally. The radius of the first circle is r and the radius of the second smaller circle is equal to 3. The two circles will touch each other internally if the distance between C1 C2 is equal to the difference of the radii, or C1 C2 is equal to r minus 3. Now as the radius of the first circle reduces, the circle shrinks in size and starts cutting the smaller circle at two distinct points. Now as r reduces, C1 C2 becomes greater than r minus 3. Let's call this result 2. From 1 and 2, it follows that the two circles will intersect in two distinct points if C1 C2 is greater than r minus 3 and less than r plus 3. But C1 C2 is equal to the distance between the points 1, 3 and 4 minus 1, which is equal to the root of 1 minus 4 square plus 3 plus 1 square, which is equal to root of 9 plus 16, which is equal to 5. Therefore, r minus 3 is less than 5 is less than r plus 3. The first inequality implies that r is less than 8 and the second inequality implies that r is greater than 2. Therefore, the radius of the first circle R must lie between 2 and 8 for the two circles to cut each other at two distinct points.